Now you speak. I think now it will be. Now it is audible. Okay, we will start class after 1 minute. Okay, then we will start the session for tomorrow. So my name is Sunny Kumar Sharma and I am a PMRF scholar in IIT Kharagpur. I will be taking an interaction or problem solving session for traction engineering course of NPTEL, which is taught by Professor Ibzur Rahman. We have already done four weeks, and this is fifth week, in which we will be solving some questions which I already gave. So Sivarman, have you done the previous questions? Sivarman, have you solved this question?
No, sir, I didn't see.
Uh, you have not solved, right? Okay, we will be discussing it here. First of all, we will be giving a brief summary or recap of all the 4 weeks. Bhagyasri Yonorkar, are you there? Bhagyasri. Bhagyasri, am I audible? You can write in the chat box. Okay, let me first give you a uh, brief of week 1, 2, 3, and 4. In first week, in all this last weeks, we have learned what is traction, in which we have seen uh, four types of wheel. What are those four types, Sivaraman? Can you tell? Do you remember? One is self-propelled, other four you tell.
Tool wheel,
Okay, road wheel,
entry wheel,
brake wheel,
powered wheel.
and power wheel. Yes. This thing we have already discussed. Tire terminology, we have already discussed what is section width, section height, is overall diameter, how to calculate, you must be remembering. Tractive performance parameters, those 5 parameters we have already discussed. Uh, Sivaraman, what were those 5 parameters? Motion distance ratio,
Traction ratio,
net traction ratio,
loss traction ratio,
gross traction ratio,
slip
slip or travel reduction ratio. Last one,
Efficient. Factory efficiency.
factor efficiency. Measurement of soil strength, we have already done how to find Kc, K5 and N. Do you have any doubt here? Everything is clear, I think. In traction performance prediction models, in last lecture, we have discussed two models. First one is Wismer and Luke, and second one is Brixes. According to Wismer and Luke, what is the formula for motion resistance ratio? Do you remember, Sivarama?
1.2 divided by Cn plus 0.04.
Yes, correct. The Cn is wheel numeric. And what is the formula for gross traction ratio? Music?
0.75.
No, no. 0.75. Yes, 0.75 into 1
minus e to the power of minus 0.3 Cns.
yes, correct. And in Brixes, what is motion resistance ratio? Air mobility number will come into action. 1 by Bn. Bn is mobility number plus 0.5 S by root 100 mobility number plus 0.04. This in case of Brixes. What is difference in this wheel numeric and mobility number? What is formula for wheel numeric? CIBD by W. And mobility number is CIBD by W into 1 plus 5 del by H. Head deflection will also come into action and 3B by D. This is mobility motion resistance ratio, and gross traction ratio given by Brixes is 0.881 minus 0.1 mobility number into 1 minus e to the power minus 1.75. Okay, I don't remember exactly. And into S plus 0.04. 0.04. Thus, here a gross thrust Brixes is telling that it is 90, it can be achieved 92% of the weight coming on the wheel. And in this case, in Wismer and Luth, only 75% of weight can be converted into gross thrust ratio. And Wismer and Luth took how many number of parameters? They took 9 parameters, and Brixes 11 parameters. This thing we discussed last week. This question I gave to you. We will discuss the solution here. A 50 HP two-wheel drive tractor with a total weight of 2400 kg has the option of fitting either 13.628 or 16.928 tire on rear axle. Select the suitable tire size. If the tractor is to be operated most of the time in horizontal surface areas with an average cone index of 1200 kPa with a static weight distribution of 35% and 65% at front and rear axles respectively. Assume del by ratio 0.2, aspect ratio 0.75. There is no weight transfer during its operation. First, there are two wheels. Wheel 1, first wheel and second wheel. One wheel has dimension 13.6 into 28 and second wheel has 16.9 28. Sivaraman, it is radial tire or bias ply tire? Yes, because R is not here. So, and 13.6 is 13.6 is what? Width or diameter or radius. It is section width. In what, in which unit? In inches. Here also it is section width in inches. So, and aspect ratio it is given 0.75. So first you calculate uh, over diameter of the both width D1 and D2. Sivaram, you have calculated with you, right?
Yes, sir. Yes, sir.
Mm. Into the calculations. Bhavisi, can you tell that how to calculate overall diameter of a tire with this designation? If you don't know, you can tell me, I will explain. So what basically you have to do is 1.06 into 28 is ring diameter. You should multiply with 1.06. Then you have to add section height 2 times the section height, and section height is so aspect ratio into section width, that is 13.6. This will all come in inches. You have to multiply this into 0.0254 to get it in meter. Same thing you have to do here. So what did you get here, Sivarni? Same thing you have to do here. 1.06 into 28 plus 2 into 0.75 into 16.9 into 0.0254. What diameter you got, Sivarna?
Even I got as 112.175.
D1 you got
112.17.
1.27, right? It will come 1.27. Did you get this value?
Yes, sir.
And D2? D2 value, this we calculated.
Sir, due to 139.77, sir.
1 point
139.77, sir, in centimeters. So 1.39.
1.39 meters. This is correct. You have one question is that select the suitable tire. The most suitable tire will be what? Which will give more rolling resistance, right? The best tire is that which gives not more. The best tire is that which will give less rolling resistance. And rolling resistance formula is according to Brix's you have to go, because that was the better form. That was better prediction model. Why that Brix's is better? You give 1 point that why it was better.
It has more parameters than compared to the
That is
previous one.
correct. So rolling resistance according to Brix's was 1 by Bn plus
Yes.
0.5 s by root Bn plus 0.04. So you have to calculate basically Bn. So Bn will be CIBV by W 1 plus 5 del by H by 1 plus 3 B by D. So B you have calculated, you have to calculate B also, means this value. B1 you have to calculate and D1, B2. B1 is this in inches. Sorry, this is height. Don't multiply it with 0.75. If you multiply, means you have to just multiply 13.6. 13.6 was the section grade. So 13.6 into 0.0254 in meters. Just do that. What is this value? 13.6 into 0.0254. 0.345 meters. And this 16.9 into 0.0254. This will be B2. 16.9 into 0.0254.
0.421, sir.
0.421 meters. Okay. Now we will do the calculation for Bn to calculate the rolling resistance. Bn for this type is Ci d1 by weight coming on this wheel into 1 plus 5 del by h by 1 plus 3 d1 by d1. What is core index? 1200 kilopascal. What is B1? 0.345, D1 1.27 divided by weight coming on this wheel, single wheel. Weight coming on the 13.6 into 2 weight. This is front wheel, right? No. The select student at the most with notice index with a static weight distribution 35%, 65%. I think. What is weight? What will be the weight coming on one wheel? Can you tell what is front wheel and what is rear? What is front wheel in this two tire? It is 13.6. 13.61 is the front wheel. So weight coming on the front axle is 35% of 2400 kg. That is the weight coming on the whole front axle. Means 2400 into 0.35 is coming on the front axle. You have to divide it by 2. So that weight coming on one wheel will come. So you have to do the calculation here. 2400 into 0.35 by 2. Then 1 plus 5 del by h. Del by h ratio given is 0.2 by 1 plus 3 into b1 is 0.345 by d1 1.27. This will be the wheel numeric mobility number for front wheel. Sivaraman, is it complete equation, complete expression?
Yes,
Is anything missing here in this expression?
yes, sir.
This CI is given in kilopascal. This weight is in kg. You have to convert it in single unit so that you can apply the formula. To kg you convert it in Newton. That is, multiply it with 9.8. It will become Newton, and then you divide it with 1000 to convert it in kilonewton. Now it is complete. This is kilonewton. This is B into D. B into D means what? Kilopascal is Newton per meter square. B into D is meter square. Meter square cancel. Numerator is kilonewton, denominator is kilonewton. Now you do the calculation. What is wheel numeric or front wheel? You have calculator with you. Let me calculate. Sivaraman, are we going right?
Thank you, sir.
The question is asking in this two tire, and we thought that this is the both is rear axle tire only. 35% is weight coming on front axle and 65% on rear axle. So this is the true tire, so it will be 65% only. Are you getting what I am saying?
Yes, yes, yes.
This both is rear tire.
The,
There is
yes,
nothing.
the tire. Okay, sir.
Hmm. Now you do the calculation. And for wheel numeric of second wheel, for second wheel, this B1 will change, D1 will change. It will remain as it is. This B1 and D1 will change. It will become B2 by D2. Then the H is same for both the tire. It will become B2. It will become D2. It will be same. You calculate the wheel numeric for front and wheel numeric for first wheel and second wheel. What value is coming, Sivarma?
BNRE for the first one I got was 75.80032.
70.
75.80. 75.80.
75.80.
80.
And for second is
Working it out, sir.
okay. What mobility number came for second week? Bhagasri, if you're there, you can do the calculation with us. Bhagasri, are you there?
202.58, sir.
202.5.
Yes, sir.
Okay. Put both the mobility number in the following equation. 75.80 here and 202 here.
What is the value of this, sir?
For first tile it is
So what is the value of this, sir?
okay. Sleep, as I said, sleep is not given, right? There is no bit. Sleep is not given. You can take the sleep as 10% or 20%. 10% you take, that is 0.1. Do the calculation of 10%. Is 1 by 75.80 plus 0.5 into 1. 0.1, 0.05 by root 75.8 plus 0.04. 0.059, right? And for did you get this value?
Yes, sir. I got you. 0.0589, sir.
Okay. 0.0589, that we can write 0.05. And for and for 202.5, it is coming 204.5, 0.048. So which tile we need to select? Which tile will give more rolling resistance?
Second one, sir.
Second one will give more rolling resistance. Rolling resistance is motion plus resistance ratio is rolling resistance by weight coming on the wheel. Here it is 0.059. Means more of the weight coming on the wheel will be converted into rolling resistance. So more is the motion resistance ratio, more is the rolling resistance. That is simple mathematics. It is 59%, it is 48%, 5.9%, 4.8%. So yes, we are correct. This second week we have to choose. Yeah, the problem is clear, right?
Yes, sir. Yes, sir.
Hmm. Okay. Now we will see the next question. Have you solved this in the assignment? We will do it here. Okay. A two-wheel drive tractor with a gross weight of 19 kilonewton has a wheelbase of 2.1 meter. A two-wheel drive tractor has a wheelbase of 2.1 meter. Suppose this is a tractor. It has a wheelbase of 2.1 meter and it is fitted with a 616 and 13.6 bisplat tire at front and rear axle respectively. On a level ground, its center of gravity is a distance of 75 centimeter from rear axle. This distance of center of gravity is from where we take it is 75 centimeter. We will do the calculation in meters. We can write it 0.75 meter. The tractor is used for plowing a farmland with an average cool index CI is 1000 kilopascal using 2 into 30 centimeter ambic plow. An ambic plow is attached here. The total pull in the vertical plane is 250 kg. This suppose ambic plow is acting and the vertical pull, the pull in the vertical plane is 250 kg. This pull is 250 kg and it's at an angle 15 kg. It has become a slight greater than 15 kg. It is acting at an angle 15 degree with the horizontal when operated at a depth of 15 centimeter. Here the depth is also given. It is operating at a depth of 15 centimeter or 0.15 meter. Yes, sir. The point of resistance is located at 125 centimeter behind the center line of rear axle. This is the center line of rear axle and it is this point of pull is located at 125 centimeter or 1.25 meter behind the rear axle and 15 centimeter below the wheel. Okay. Determine the coefficient of traction and tractive efficiency. Coefficient of traction you need to calculate or mu and tractive efficiency. Slip is given 12%, del by h is 0.2%. So for coefficient of traction, what you will do? Sivaram, we will first discuss the procedure, then we will solve the question. What is coefficient of traction?
Gross traction minus pull, sir.
Is gross traction ratio minus rolling resistance ratio. If it is denoted as mu g, then mu g minus rho is the coefficient of traction. So basically we have to calculate what is mu g and what is rho. We will use Brix's equation only because that is better. That will give better performance. And according to Brix's, what is mu g? 0.88 into 1 minus e to the power minus 0.1 Vn into 1 minus e to the power minus 7.5, right? S plus 0.04 and rho is 1 by Vn we have already discussed. So first thing you can see is that we have to calculate Vn only. Mobility number you calculate for both the way. First, we are calculating mobility number. CIBD. We need to calculate B and D for both front and rear wheels. So BN for front we have to calculate, which will be BF and DF by W on front wheel into 1 plus 5 delta H by 1 plus 3 B of front wheel by D of front wheel. So B of front wheel is section width of front wheel 6 into 0.0254 and diameter of front wheel is 1.06 into 16 plus 2 into aspect ratio is not given, you can take 75%, 0.75 into 6. This multiply with 0.0254.
It's 65.9, sir.
Okay,
And
mm, I'm giving you the values. We will do the calculation faster. For front wheel, BF is 0.152 in meters, everything is in meters. And diameter of front wheel is, this we have done too many times, that's why I'm writing it up, 0.66 in meters. Section width of rear wheel is 0.345 and diameter of rear wheel is 1.27. You do the calculation for front wheel. CI. CI is given 1000. Here, here the most important thing is new concept which will come here is what WF you will take. That is the only thing here. What is WF?
the weight static on the front axle.
This is weight coming on the front axle, but this is not the static weight. This is dynamic weight. Dynamic weight means after the pull, everything is attached. This pull is attached and some weight transfer is there. So, what is the dynamic weight coming on the front axle? Dynamic weight means what is the reaction, ground reaction here. Suppose the ground reaction is R1 and here it is R2. So at the place of WF, you have to take reaction of front wheel by 2. And how we will calculate that RF and RR at the point here. So how you will calculate R1 or RF? RF or RF. If you will take the moment around this axis, RR axis, then you will get RF, and when you will take moment around RF, you will get RR. Suppose you are taking moment about RR, then how will you will do the balance? Do you know how to do the calculation for moment calculating RF? You have to take every moment. You have to check it is clockwise or anti-clockwise. For all clockwise, you give one sign and you equate it with 0 because everything is balanced. Suppose this pull is acting here at an angle theta. So uh, this horizontal resolution of P will be P cos theta and this is P sin theta. And P cos theta is acting is giving a wedge rotation. about this RR, clockwise or anti-clockwise. P cos theta at this distance 0.15 meter. If you shift at this point, it will act in which direction? This direction is
Clockwise.
clockwise. So you can take clockwise as positive or negative. Suppose you are taking it positive. So P cos theta is acting at a moment arm of 0.15 meter. This we have taken positive. So clockwise we have taken positive. So every clockwise we will take positive and every anti-clock we will take negative. This P sin theta at an distance at an arm of 1.25 meter is giving what type of counter clock or clock about RR. P sin theta is acting downward at this distance. So it is acting in anti-clockwise direction. Is it clear? Are you getting
Can
Sivaram?
you can you explain that how to get the RR, sir? Totally.
How to get
I'm
RR?
not getting that.
If we will do the moment balance at this RR direction at RR, we will get RF because we are doing everything from this line. What was your doubt? P
Yeah.
cos
When
theta
we are
is acting.
determining the RR,
Yes, from this equation, what will come here, we will get RF, and for RR we will do the moment arm. Uh, we will do balance the moment arm for RF. Then we will get RR. So first we are calculating for RF. That was your doubt, right?
sir.
Hmm. So P cos theta is acting clockwise, and we are giving it positive. P sin theta is acting in anti-clockwise. We will take it as negative. P sin theta into at an arm of 1.25. Then weight is acting at a distance of 75 meter. In which direction? Clockwise or counterclockwise? Weight is giving clockwise effect or counterclockwise effect about this RR. Sivaraman?
Clockwise, sir.
Clockwise. So clockwise we have taken positive. So it is W at an arm of 75 centimeter, 0.75 meter. Then we have RF, unknown value RF. RF is acting at 2.1 meter, and it is giving this effect, means this is giving counterclockwise effect, means it is minus of RF at a distance of wheelbase, that is 2.1 meter. This you equate with 0. So you will get RF as P cos theta into 0.15 minus P sin theta into 1.25 plus W into 0.75 divided by 2.1. This is the value for RF. Every unknown, nothing is unknown here. Means P you already know. It is 125 to 50 kg. This you convert in Newton. If weight you will convert in Newton. Means if weight coming is 19 kilonewton, so you convert it in kilonewton. 250 kg into kilonewton. That is 250 into 9.8 into 10 to the power minus 3. You put that this P here, theta is 15 degree, then W you have 19 kilonewton, you will get RF. So is it clear that how we calculated RF? Sivaraman.
Yes, I think so.
So you will put this value in calculator, or I will just, or I need to just tell. RF will come. I have the value with me. This RF will come when you will do this calculation. You want to do the calculation, or I will just tell.
Calculation, sir.
You are calculating. Okay. Put P in kilonewton because W is in kilonewton. What value of RF you got?
So, why did it say 6,570,000?
What you got? RFS
6,577, sir.
6577. You have done it in Newton, right? 6577 in Newton. W you have converted in Newton. So you can do it in kilonewton. That will be easy for you. It is 6.57 or 58 kilonewton. So now you will tell me that what will be the moment balance for around R we have already done for RF. How will do the moment balance for around RF. what will be the direction of P cos theta, P sin theta? Means what will be the sign, means negative or positive? P cos theta, P sin theta, RR and W. There are four terms. We are doing the moment arm around RF. So what will be the direction of P cos theta? P cos theta at this distance, it is acting, you shift it here. Means suppose 0.15 meter, P cos theta is acting in this direction. So it will try to move this center around this direction. So it is clockwise, right? Again, you can take clockwise as positive. Means P cos theta is acting at a distance of 0.15 meter. Now, what is about P sin theta? This is acting at this is acting from here to here. It is 2.1 plus 1.25. 1.25 plus 2.1. At this distance, our P cos theta is acting. And in which direction? P sin theta is acting in counterclockwise direction. Right? It will be same for RR and RF. If you have taken P cos theta positive, then P sin theta is negative, and it is acting at a distance of 2.1 plus 1.25, that is 3.35. P sin theta into 3.35. Then RR is acting at a distance of 2.1 meter and is trying to rotate it in this direction. It is clockwise. Means RR is acting in clockwise, we are taking positive clockwise, so RR at a distance of 2.1 meter, and W is trying to rotate it in this direction, that is anti-clockwise. Hence minus W at a distance of 2.1 minus 0.75. 2.1 minus 0.75 is equal to 0. This will give RR. RR is equal to W into 2.1 minus 0.75 plus P sin theta into 3.35 minus P cos theta by 2.1. Do you have any doubt here, Sivaram?
Previously, by using RR, we derived the formula for the RF measure
By using
below one in
R
the
we calculated RF. And now
so that
by using moment arm around RF, we will calculate RR. So what is your doubt?
yeah,
You
but
can do the
in this
subtraction also. Total weight coming is, I think, 19 kilonewtons are there.
yes,
You can
now we now we got the value of RF equals to 6.5 kilonewton measure. If we substitute this one in that color detects one RF now, then we will be also getting the value of RR answer.
if we substitute this value of RF in which equation?
Like below you gave the color fix measure.
Below, in the below expression, there was no notation of RF. Means RF was there. In this equation there is no mention of RR. So how can you calculate RR from here? You can calculate RR from what you are telling is right. We can have an equation for for RF, and that will be what that will be RR plus RF. This RR and RF is balancing the weight. So it is balancing the weight, not only weight but also this P sin theta. This I am giving you a shortcut. If you don't want to do that momentum analysis, you directly do RR from here. So RR will be W, that is 90 kilonewton, minus P sin theta, that is, you do the P sin theta, minus RF is 6.58. You do either this or you do either this, you will get the same value. Did you get it? This is a very useful concept for calculating the RR and R. You can also cross check that.
P sin theta is a draft, no sir. P sin theta is the draft given by the implementer, sir.
No, it's not clear. What you said?
You gave the equation as RR plus RF is equals to W plus P sin theta, no sir.
Yes.
In this equation, the P sin theta signifies the draft from the implementer. Am I right,
Draft
sir?
is no, draft is the horizontal component of the pool. Draft is P cos theta. That is the basic concept. Draft is P cos theta. Only the horizontal component of pool is called draft, not vertical component. Vertical component will add weight to R, means add in ground reaction. Means RR plus RF will be balanced, will balance W in P sin theta. Is it clear? This is due to pull, not due to draft. You are saying is correct, but you are you are just using a different term. This P sin theta is due to pull. You can cross check that these two value will come same. RR will from this equation, RR from this equation will be same. If you want to do the calculation, you can do both the calculation. You are doing this calculation or this calculation.
Above one, sir.
Okay. Venkat Hemant, are you there? Venkat Hemant, can you raise your hand if I'm audible to you? Okay, we are solving a question on numerical problem in which there was a tractor fitted, the tractor tire, hello, the tire designation was given and the weight coming on the tractor was given. Pull was applying, a pull was there on the tractor. Okay, you can lower your head, right? A pull of 250 kg was applied on this tractor, and we need to calculate what is the rolling resistance, what is the coefficient of traction of the tires, and what is the tractive efficiency. For coefficient of traction, if you have missed the class, coefficient of traction mu is equal to gross traction ratio by minus rolling resistance. And mu you have to calculate from Briggs equation, and rho also from Briggs equation. So in both formula, mobility number will come, and for mobility number, you have to calculate CIBT by W, and this W is dynamic weight. For this dynamic weight, you have to know that what is the ground reaction at the front and rear axles. So for front axle, we have calculated RF, and now we are calculating RR. RF came as 6.58. RR, Sivaraman is doing the calculation. Did you get it, Venkat?
Sir.
Do you have any question from here?
No, sir.
You know how to calculate RF and RR, dynamic front and rear wheel reaction. You have to do the moment arm analysis of at both the wheels. Moment arm at around RF, you have to do the analysis. Here it is P cos theta, it is P sin theta. This P cos theta moment arm and P sin theta moment arm, then RR and W. Yes, gone. So what RR did you get?
11.788, sir.
11.7. 11, right?
Yes, sir. Yes, sir.
11.78. So what you can
But
observe,
I'm not getting
11.78 plus 6.58, if you add, is it, I think it is not correct. You got a wrong value. It can never be less than weight, because this RR plus RF, this RR plus RF, it itself is greater than W, W plus P sin theta. If you do the addition, it is 18.46, and total weight W was 19 kN. It should be greater than 19 kN. The value which I have got is 13.06. 13.06. You do your calculation again. You can cross check. It will come 13.06, and it is 19.64. Means 0.64 kilonewton is P sin theta. Did you get? Sivaraman, did you get it?
Yes, sir.
Okay, means R is 13.06. If you want to do recheck your calculation, do you want to recheck? The longest part we have already done. Now we will move to mobility number, then motion distance ratio, then gross traction ratio. So motion distance ratio for front wheel is one mobility number. So you have to first calculate the mobility number for front wheel is equal to CI D for front wheel, D for front wheel by R of front wheel by 2. Why 2? Because RF we have calculated for front axle. We have to divide it by 2 for one wheel. We use this formula for one wheel into 1 plus 5 del by H by 1 plus 3 width of front wheel by tire of front wheel. DF is given here, DF is given here, RF is given here. And CI is 1000, I think. Yes, it is 1000 kilopascal. This is already kilonewton. You just put all the values here, you will get the mobility number for front wheel. What was the mobility number for front wheel?
14 total.
What value? What value you said?
1 minute, sir.
Okay. Ah.
96.08.
36.08, right?
Yes, sir.
Yes, that is correct. Bn for rear, you will calculate everything is given in this side. Br, Dr and Rr. Rr you have to divide it by 2. Bn for rear wheel is 73.94. I'm telling you the value. You calculate it for motion resistance ratio. Okay, I'll tell you motion resistance ratio for front and rear. You have to just put this Pn here. So you don't need to calculate. The value is for front wheel it is 0.23. 0.23 and for rear wheel it is 0.17. Bn for front wheel is 36.08. Bn for rear wheel is 73.94. Motion distance for front wheel is 0.23. Rho for front wheel is 0.23 and rho for rear wheel is 0.17. Rho we have already calculated. Now we need to calculate what mu g, and mu g is 0.88 1 minus e to the power minus 0. This is for front wheel 0.1 bn for front wheel into 1 minus e to the power 7 minus 7.5 slip plus 0.04. Now you do this calculation for front wheel and for rear wheel. You do this. You need any value? Sivaramam, bn for front wheel I have written here. Bn for front wheel is and slip is given here, it is 12%. Slip is 0.1. This way you will get mu g for front wheel. and mu g for rehearsal. Uh, do you need, is it taking more time? So, do,
From using fx equals to 0.547. Correct, sir?
0.547. Okay.
Now I'm working it out for easy answer. One
Okay.
more, sir. UGR is 0.556, sir.
0.556.
56, sir.
I got it as 0.52. I don't know which one is correct. Okay, we will take your answer 0.56. Mu front is 0.547 or 0.55 and mu r is 0.56. Now we have reached the answer of this question. It will clear it will have cleared all your concept of traction. So the thing which is asked is coefficient of traction mu. This is nothing but mu g minus mu g minus rho. Coefficient of traction for front axle, it will be this minus this, and for rear axle will be 0.56 minus 0.17. And for whole tractor, what will be the coefficient of traction? if you will be asked, if you have been asked that what is the rolling resistance for tractor, then for means all the four tires, what you will do? This is rho F for one wheel. Rho F is rolling resistance by dynamic weight. This is for front wheel means RF. It is RF, but this is RF by 2. This is RR for front wheel, front axle. If you want to do it for one tire, then it is RF. You have to divide it by RF by 2. Then you will get it for one tire. Means RR for one tire will be RF by 2, and this is 0.23. Are you getting what I am trying to say? The rolling resistance for one wheel of front axle will be RR for one wheel by RF total, this total axle reaction by 2. In this value you have to multiply by 0.23. 0.23 into RF by 2 is for one wheel of one wheel of front axle. If you multiply it by 2, you will get for rolling resistance for whole front axle. Same way you will do it for rolling resistance for rear wheel. You will multiply it by 2, you will get the rolling resistance for rear axle. If you multiply the rolling resistance of front axle and rear axle, you will get the rolling resistance for the tractor. Is it clear? Sivaram?
Now, uh, we should be having both the axle also, rear axle as well as the front axle.
Yes, RF is for front axle, not for front wheel, one wheel. If you will divide it by 2, you will get it for one wheel. This row of we have calculated for one wheel. It is always calculated. So
In order
0.23
to get one axle, we should be multiplying with 2.
with 2,
And
yes.
after multiplying, by adding both the axle of the front wheel and rear wheel, which will be
You
giving the overall total.
oh, yes, right. The same way you will do it for cross traction force. Then this will give you mu g for tractor. If you want to do the coefficient of traction from there, you can also do coefficient of traction will be gross thrust minus rolling resistance for whole tractor by RR, means dynamic weight on tractor, which is W plus P sin theta. This will become more lengthy. Did you get the concept? This is very lengthy problem. And one more thing asked is what is tractive efficiency? I will tell you, just you don't need to calculate. Tractive efficiency formula, do you remember? In terms of mu and mu z.
Cross axle by
That is universal, means general formula. In terms of mu and mu z, it is mu by mu z into 1 minus s. Sorry. Do you know this formula? Sivaram, do you know this equation? Okay, if you don't know, then you can tell I will derive it here. If you know, then it is fine. So mu and mu g you will take for front or rear axle. Tractive efficiency is calculated for front axle or rear axle. This is a two wheel drive tractor, na? So for two wheel drive, it is means axle power is coming on the rear axle. So this mu is mu g for front rear axle minus mu g minus rho for rear axle by mu g for rear axle into 1 minus slip is 0.12. Mu g for rear axle is 0.56. You don't need to calculate. I will just tell you 0.56 minus for front, for rear axle row R is 0.17 by 0.56 into 1 minus 0.12 is 0.88. This is the tractive efficiency of the tractor. This you can calculate. Okay, you just calculate it. That what tractive efficiency is coming. What is the tractive efficiency?
0.612, sir.
Sorry,
0.612, sir.
0.612 means 61.2% is the tractive efficiency of this tractor. If you would have been asked to calculate the tractive efficiency of the wheel, then you can imagine that how lengthy this question is. So everything is clear regarding this. Too many concepts has been covered in this question. So everything is clear. Okay. This question is also very lengthy. This we will leave for next week. Here also too many concepts are covered. Uh, that we will solve in next class. We don't have time enough to solve this question here. This is also very interesting problem. You will learn a lot in this question, and one conclusion will also come from this question. We will leave it for next week. Next we will do 1 2 question. With an increasing tire diameter, the coefficient of traction increases or decreases or remains same, or first increases then decreases. You tell if you have seen this lectures.
Okay, sir.
Yes, that is correct. Means you have seen you have completed those lectures, right? Okay. Here is graph which is telling the effect of tire diameter on and tire width on coefficient of traction. So the earlier question was, with increasing tire diameter, what is the effect on coefficient of traction? It increases, and the highest value is for highest cone index. That we have discussed in our previous sessions, that why with more increasing cone index, the we get more coefficient of traction, we get more cone. And for a lower CIE value, the increase is very rapid, and for higher coefficient, for higher cone index, the increase is not so rapid. There is a very slight increase with increasing diameter. This test is done in IT Kharagpur here only, and this conclusion has been drawn. With increasing tire width also, the effect was drawn, and the effect of tire diameter and tire width on coefficient of rolling resistance, it will decrease. This, with increasing tire diameter, coefficient of rolling resistance decreases, and this is very rapid in loose soil or having or soil having cone index very low. The rolling resistance decreases very fast. This is also shown in this diagram. Is it clear? Okay, for same diameter and same width of single and dual tire, if this is a tire of width B and diameter D, and this is another tire of same width, means this is B, or in here it is B1 and B2, means B1 plus B2 is B, and it is also having same diameter. Then which will perform better? For same diameter and
We
same
will be
width.
able to perform. This is option D, sir.
Option D.
Is B, sir.
D, B. Yes, you're correct. So that is means can you tell why? Yeah, or how?
Sir, the efficiency decision between a single tire and team sir can be defined by the uh, mobility number, sir.
Mobility number, yes, very correct. Mobility number you calculate for single tire, and mobility number you calculate for dual tire.
Same, same dimensions. The dual tire will be giving the dual tire is more efficient than the single
Yes,
tire.
very, yes, that is correct statement. And if you want to visualize it with mathematically, then you can do the calculation for you will calculate mobility number for single tire, that is CIBD. For single tire, width is B and D is diameter by W into 1 plus 5 for the deflection if you calculate, then 1 plus 3 B by D, and for dual tire it is CI width will be B1 and D will be same by for on on a single wheel of dual tire, weight coming will be distributed. If you divide it by 2 means weight is distributed equally. If you consider, then C by B1 D by W by 2, 1 plus 5 del by H by 1 plus 3 B1 by D. If you divide both the equation B and S by this whole equation, what expression you will get? This is for one wheel. Dual tire, single wheel we have calculated mobility number. But in dual wheel we have two tires, so we will multiply by CIPD. In CI is in both the CI is same for both tire. D is same, W is same, 1 plus 5 del by H is same. So what is left here? B by this 2 will go up, 4 B1 is left here, 4 B1, 1 plus B by D will come down, and this B1 by D will go up, means 1 plus 3 B1 by D by 1 plus 3 B by D. So if B and S by B and D is greater than less than 1, this means that dual will perform better. And if it is greater than 1, then single will perform better. But if you will observe, when you will observe this equation, you will find that the denominator will always be greater. So dual will always perform better than single will. That is the conclusion from this derivation. For different diameter also, you can conclude this. If you take D1 here, D2 here, then what will be the condition under which dual will perform better? That you can derive from this procedure. That what conditions should we take that dual will perform better? Is it clear? Okay. You are very sincere student. You take classes regularly. So this question we will solve in next class first. It will cover too many concepts. Then we will be also having some this type of questions, MCQs. So is it okay for today?
Yes, sir.
Okay, Miss, or any doubts from the weekly assignments? I think there is. Okay, okay, okay. Yes, you are unmuted. You were saying something. Is there any doubt from weekly assignment? There is a live interaction session from with Rahman sir, with Professor Hizur Rahman. That is on Monday. Do you know that?
Yes, sir.
So if you have,
Can you,
hmm, yes, you were telling something.
uh, give me the timing, sir? What is the timing, sir?
Timing. Didn't you receive the mail? I think it is there in second half. That is for sure. Exact time I can tell you if you provide me your email ID.
Yes, sir.
You write it in the chat box.
Yes, sir.